Hey, what's going on, guys? So, over the weekend, I assigned you a video to watch done by Khan Academy about position versus time graphs, and then there was a Google form that you had to fill out with questions about a position versus time graph. And so that's actually the same type of questions we're going to be answering in class today. But then I thought to myself, well, what if people didn't understand it over the weekend? And I never really explained it. I just gave them a video, and I didn't really have a chance to teach it myself, and there's some things they didn't understand. So I decided I was going to make my own video explaining some of the same things that he did as well as some others and try and make it clear or explain it in a different way. So hopefully if you didn't understand it the first time, this will actually give you a chance to learn it again and hopefully help you understand it better as we go on. So we're going to stick with these type of graphs for a few days to practice with them, learn what they mean, how to interpret them, and so on. All right, so as the guy in the video said, this is a position versus time graph. That means that on the vertical axis, we measure position of an object or its location on a number line, as we've been saying. And on this axis, we measure time. So this path, this blue path that you're seeing right here, does not show you an object moving around, going forward, taking a turn, coming back. It's not following a curved path of any type. It's following a straight line. I'm going to explain what I mean by that. So for purposes of this graph, we're going to assume that the object is me. There's a picture of me right down over here in the corner. Here, what? I'll make it bigger. See? There I am, right there. Picture's a little blurry. I'm going to be the object. So this does not mean that I went over here and then I went this way and then this way and then this way. That's not what the graph is showing. The graph is showing motion in a straight line. The axis at the bottom just shows time, where I happen to be on that number line at any given point in time. So, for example, at the very beginning, my position at time 0, so time 0 right there, my position is 0 meters. So at the very beginning, I'm at 0 meters. And you can see that over here on the number line. I'm right there. I'm by 0 meters. So where do I go once the clock starts? Well, in the first second of my motion, so the first second would be from here to here, 0 to 1 seconds, I move from 0 meters to 1 meter in a straight line. So that would be I moved upwards like this. Or what happened was I was at 0 meters and I moved to 1 meter. Now, I haven't necessarily said why I'm moving. So let's pretend, for example, I was standing at a certain spot and I happen to look down the hallway and I see my wife. I love her very much. She's beautiful. So I'm like, hey, I want to go talk to her. So I start walking forward. In the first second, I move 1 meter forward or up the number line. That's positive motion. More on that in a second. And then what happens in the second of motion or the next second? Well, next second of motion here, I go forward another meter. So there I go forward another meter. And I don't want my picture to be upside down. So we'll try and do it this way. There we go. Okay. So now I'm at 2 meters. And then as you can see from the blue line, the same thing keeps happening. Every second, I go forward another meter. 1 second passes, go forward another meter. So the little black lines I'm drawing are just showing you time is passing, another second of time has passed, and I've gone forward another meter. But really what I'm doing is just going up the number line. So I go all the way to 5 meters in the first 5 seconds. So it took me 5 seconds to go from 0 meters to 5 meters, just in a straight line, 5 meters, 5 seconds. Well, what happens next? So after 5 seconds, so at 5 seconds, I am here at 5 meters. And then at 6 seconds, I'm still at 5 meters. At 7 seconds, I'm still at 5 meters. At 8 seconds, I'm still at 5 meters. 9 seconds, 10 seconds. So for a whole 5 seconds, I stay at 5 meters. In other words, I don't move at all. So the whole entire line, which is horizontal, that portion from 5 to 10 seconds, I'm not moving. So anytime you see a horizontal line, you know the object's position is not changing. It's sitting still. It's not moving. Now keep in mind, the first part of it, I had positive motion. So I was going up the number line. So anytime you see the line going up and to the right, that's positive motion. So I had positive motion from 0 seconds to 5 seconds. Then I have no motion or sitting still from 5 seconds to 10 seconds. So on the questions that were being asked of you on the Google form, and what will be asked of you today, is during what time periods does the object have positive motion, negative motion, or sitting still? So it says what time periods. It's not asking for the position, it's asking for the time periods during which you had positive motion. So in this case, from 0 seconds all the way to 5 seconds, I had positive motion because this line was going up, where I circled it here. From 5 seconds to 10 seconds, this time period, I was not moving at all, so I was sitting still. All right, let's get some of this stuff out of the way. What happens during the next few seconds? Well, from 10 seconds to 12.5 seconds, I'm moving back down the number line. So in the next 2.5 seconds, I move all the way back, and that picture keeps resizing on me. There we go. Move all the way back down to 0 meters, right there. So I took 5 seconds to walk 5 meters forward, or in a positive direction, up the number line. I stood still for 5 seconds. Maybe I got to my wife and I talked to her for a few seconds. Hey, how you doing, honey? So on. And then I decided, oh, hey, I got to get back to wherever I was. And so in the next 2.5 seconds, I walk backward or down the number line or back the way I came, all the way down to 0 meters. So I ended up right where I started. That would be the last part anyway, negative motion. So anytime you see the line going down and to the right, we have negative motion, right? I was moving down the number line here for this time period. So for 0 to, not 0, but 10 to 12.5 seconds, I went in a negative direction. The line went down. So from 0 to 5, right here, that's positive. From 5 to 10, again, on the time axis, I'm looking for time periods, there's 0 motion or sitting still. And from 10 to 12.5, it was negative motion. So positive, 0, negative. All right, so that was the first question you had to answer, the first few questions. During what time periods does it have positive or negative motion, sitting still, and so on? So another question that could be asked is, during what time period is the object going the fastest? I did not ask this on a Google form, but it will be asked on the assignment for today. So how do I know where the object's going the fastest? Well, I need to look for the time period during which the object covers the most distance or the most change in position in the least amount of time. So I'm looking for a big change in position, like this, in a very small amount of time. Another way of looking at that is to say I'm looking for the portion of the line that is the steepest. I'm looking for the steepest section, and that will be where the object's moving the fastest because it's covering the most distance in the shortest amount of time. In this case, that's right here. That's the steepest portion. I went 5 meters in 2.5 seconds. Here, I wasn't moving at all, so it can't be that one. Here, I went 5 meters in 5 seconds. So I went 5 meters and it took me 5 seconds, but it only took me 2.5 seconds on the last portion. So it can't be this one. We're looking for the steepest one. That one right there. Steepest portion equals fastest. If you're watching this and you're in the physics class, you will be expected to calculate what that velocity was during the time when it was moving the fastest. So if you're in the physical science portion or physical science section, you don't have to do this, but in physics you will. So during the steepest portion, which we said was this portion right here, that portion is the steepest, how fast was I actually moving? Well, I went -5 meters, and I'm just going to count 1, 2, 3, 4, 5. I went -5 meters in 2.5 seconds. So -5 divided by 2.5. So that comes out to be equal -2 meters per second. The way the guy in the Khan Academy video explained it, it's the slope. You're just finding the slope. Rise over run, or you do, x2 minus x1 over t2 minus t1. And he explained that, very thoroughly. So I'm not going to go over all of that again, but basically you're just finding the slope. But you want to know the number of meters divided by the number of seconds that passed. Or another way of looking at that is change, this little triangle symbol means change in position, x, divided by the change in time, t. That's another way of noting it. Any of those would work. Point slope form, you could do rise over run, you could do like I did it, count and divide, but one way or another, you find the velocity that way. So if you're in the physical science class, I won't be asking you to do that, but if you're in the physics class, I will. However, there are a couple things that everyone needs to know still, and these ones were the most missed out of all the ones in the Google Forms. It was displacement and distance traveled. So I'm going to start with the easy one, displacement. Displacement is just the difference between my starting and end points. In other words, how far away from my initial position did I end up? So we said that I started out at 0 meters and then went forward 5 meters, stayed there for a few seconds, came all the way back and ended up at 0 meters. So I started at 0 meters and I ended at 0. So in other words, my displacement is nothing. 0 meters. I ended up right back where I started. I started at 0 meters, and at the end, all the way out here at 12.5 seconds, I'm still at 0 meters. No change. So the displacement is just the difference in position between your start and end points. If I'd have ended up out here at 5 meters, my displacement would have been 5. I started at 0, ended at 5. I would have had a positive displacement of 5 meters, but I didn't. I came all the way back. So therefore, 0. All right, one other thing that was pointed out in the video that a lot of people missed was not just displacement, but distance traveled. How far did the object actually move? Or in this case, how far did I actually walk during the whole entire time? Regardless of direction, not talking about how far from my starting point. Distance traveled is literally how far I walked total. So we can work that out. So we said in the first segment, from 0 to 5 seconds, right here, from here to here, 0 to 5 seconds, I walked forward 5 meters, right? 1, 2, 3, 4, 5. I ended up out here at 5 meters. So during that portion, I walked 5 meters. So I said during that time I was walking to meet my wife, so I walked forward 5 meters there. During this portion, 5 seconds to 10 seconds, or here to here, I didn't walk anywhere. I stayed right at 5 meters the whole entire time. So I didn't go anywhere, so that's nothing. That's 0 meters. I didn't travel anywhere. So far I've walked 5 meters. I walked 5 meters, then I stopped for a little bit. Then, in this portion, from 10 to 12.5 seconds, I came all the way back down to 0. So I went 1, 2, 3, 4, 5 meters back down the number line. So, oops, sorry about that. All the way back down to 0 meters. So I walked 5 meters back the way I came. So I walked 5 meters. So I walked 5 meters forward, stayed there, and walked 5 meters back. So that's literally just 5 plus 5, which equals 10 meters. So literally you just add up all the back and forth motions on the graph and get a total distance. Notice I did not call this last one negative. Even though it was negative motion, I just wanted to know how far I walked, period. Without denoting the direction, it's just 5 meters. So displacement is how far I end up from my starting position. I ended up right where I started, so that would be 0. And the distance traveled is how far I actually went, all the back and forths added up. So I went forward 5 meters, stopped, and came backward 5 meters. And again, I'm looking at the position axis for that, and my little marks here were me showing you I was counting how many meters I went forward, and I was counting how many meters I went backward, each block being 1 meter, each block being 1 second of time down here. So I hope that helps you at least a little bit to understand better with perhaps a simpler graph and sort of less mathy. But one way or another, if you have questions, you can always ask me, put comments on your assignment, things like that. Try and get a hold of me, and I will do the best I can to help you out.